Paper 1, Section 1, Tropical Storms. Did you know that hurricanes, typhoons, and cyclones are all the same thing? They are all huge storms. It's just their location that gives them different names. Tropical storms are found usually around the equator. And did you know that tropical storms lose their energy when they reach land? Before we look at tropical storms, we need to learn about global atmospheric circulation. It concerns the atmosphere, which is the air above and around us. It's the movement of air in the atmosphere, across the planet in a specific pattern. When we talk about high pressure, we mean sinking cold air. And when we refer to low pressure, we mean rising hot air. Cells are regions where the air moves from low to high pressure. There are three types of cells: Hadley, Ferrel, and polar. Surface winds move between the cells, and due to the Earth's rotation, these winds curve and change seasonally. So how does global atmospheric circulation decide our weather? Well, the deserts are found near the tropics because there's high pressure, little rain, and hot daytime temperatures. It's hot and wet at the equator because there's low pressure weather, and it's closest to the sun, and low pressure air, where hot air rises and condenses, causing heavy rain. And it's cloudy and wet in the UK due to the polar air from the north and subtropical air from the south meeting, forming clouds and rain. Now, back to tropical storms. How do they form? Well, to form, tropical storms require three conditions. Ocean temperatures need to be at 27 degrees Celsius or higher. Strong winds and evaporation are needed to power the storm, and the spinning Coriolis effect of the Earth's rotation. Tropical storms form when the ocean temperatures reach 27 degrees Celsius, causing the water to evaporate, producing water vapor. This water vapor rises quickly and draws more warm air with it. As it rises, the air cools and condenses, forming cumulonimbus clouds. Then, the Coriolis effect causes these clouds to spin like whirlpools. The drawing shows what a tropical storm looks like. In the center we have the eye of the storm, which is a column of rapidly sinking cool air. It's a calm area with no winds or clouds. Around the eye we have the eye wall. The eye wall is the most dangerous part of the storm, which brings strong winds and torrential rain. And surrounding the eye wall are cumulonimbus clouds, also called rain bands, that swirl around and bring in more clouds with it. So what's the link with global atmospheric circulation and tropical storms? Well, unstable rising air around the equator, near the Hadley cells, encourages evaporated air to rise, condense, and form storm clouds. And since winds blow from high-pressure belts, such as in the tropics, to low-pressure belts around the equator, these winds are responsible for the east to west storm paths. How does climate change affect tropical storms? For starters, since climate change is warming the Earth, this means that oceans further from the equator are reaching that temperature, 27 degrees, required for a tropical storm to form. Therefore, tropical storms are starting to occur closer to the tropics. However, there is little evidence suggesting climate change is causing more tropical storms, as increases in some areas seem to balance out with decreases in other areas. But there is increasing evidence that storms are getting more intense because of climate change. As warmer, moist air rising provides extra energy for tropical storms, and wind speeds have potentially increased. Let's look at a tropical storm that happened. Cyclone IDAI is Africa's deadliest cyclone on record. The Category 2 storm made landfall in Mozambique in March 2019 and brought widespread destruction to Mozambique, Zimbabwe, and Malawi. We will be looking at the effects and responses of this cyclone. The primary effects were 1,300 people were killed, mostly by drowning. 90% of Beira, a city in Mozambique, was destroyed by strong winds and a storm surge. 600 houses were destroyed in Zimbabwe, and agricultural fields and houses were flooded in Malawi, leaving many without food and shelter. The secondary effects were dams collapsing and 2 hydroelectric power plants were damaged in Malawi. Mudslides affected rescue efforts in Zimbabwe. Lack of sanitation and clean water caused 4,000 cases of cholera in Beira, and 700,000 acres of crops were destroyed. And the immediate responses were boats and helicopters were used to rescue stranded people and drop off food. The World Health Organization provided 900,000 cholera vaccinations and anti-mosquito nets, and 140 evacuation centers were set up in Mozambique. And the long-term responses were Dutch engineers helped restore water supplies in Beira. The charity CAFAD rebuilt schools and supported local farmers, and the early warning system was improved to help people if a tropical storm occurs here again. So what can we do to reduce the effects of a tropical storm? We can monitor and predict them through satellite tracking. This can tell us the path of the storm, its size, and its likely impacts. Hurricane warning systems in the North Atlantic warn people if a storm is coming. To protect against tropical storms, shutters are placed over windows to protect them from smashing. Reinforced walls and roofs to protect them from flying debris, and building on high ground, storm drains, building houses on stilts, and sea walls to protect against a storm surge. We can plan for storm through educating people on what to do in the event of a storm and the dangers of them. And the media can raise awareness to help notify people at risk. Thanks for watching. I hope you enjoyed learning about tropical storms.